After we discussed the relation between IP progress and mobile network progress and how mobile network progress affect directly IP MPLS progress, now we are going to start the introduction of IP technology. The main course we would like to discuss about today and the main technology is OSI 7 layers, which called Open System Interconnection, which was invented by ISO as a standardization for data network module. We are going to discuss that deeply to understand why we created like that 7 layers and how it affects our network completely. All manufacturing in our life, and especially for communication and the programming for nowadays, consists of modules, so that the whole structure consists of number of modules. If we take the same idea as one manufacturer company which create or which build or which making a pen, for example. Pen doesn't consist of just one piece. It consists of number of pieces or number of modules. When we assemble those modules together, it gives me the complete pen. The same idea exactly ISO used to create OSI 7 layers. So accordingly, OSI 7 layers make the data network communication as number of modules, and each module is responsible for point of network communication or that IP data communication. So the main reason to create those modules, first, to simplify IP network architecture. The second point we can take benefit from this module structure is to differentiate between team responsibility. So I will make first team responsible for first layer, second team for second layer, and so on. Accordingly, when we create those modules, I will enhance user understanding. User will be easy to understand the network structure, how network communicate together. Easy to troubleshoot because I will define first the problem in which module or which layer, and accordingly I will send people who are responsible for that layer or that module to troubleshoot the problem. The main idea which has been built to make OSI 7 layers is the encapsulation. Encapsulation means each layer encapsulate its header and its trailer and send to the next layer, as we are going to see later. After we discuss that we have number of layers or number of modules, as we discussed later, we need to understand very important concept which called protocol. In each layer, according to its responsibility, it's going to use something called protocol. What is the meaning of the protocol? Protocol is the agreed way of communication. If we imagine that according to digital communication. In digital communication, we have something called 1 and 0. If we imagine that 1 is simulated by 5 voltage, 0 is simulated by 0 voltage. Another system is going to use 1 by 10 voltage, 0 by minus 10 voltage. If those two parties communicate together, they are not going to understand each other because the logic they are using is not the same. Accordingly, I'm going to receive very high bit error rate, and two systems cannot communicate together. So this is the main idea of protocol. Accordingly, parties who are going to share in that communication, that means transmitters and receiver, should use the same protocol so that they can have successful communication together. Accordingly, for each layer, as we are going to list later, each layer has its own protocols. Means physical layer has its own protocol, data link layer has its own protocol, network layer has its own protocol, according to responsibility of each layer. The most important concept here, protocol can be standard, that means it's created by RFC, or general for any vendor can use it, or can be vendor specified. That means Cisco itself can create special protocol for itself. If the same protocol need to be used by Huawei, it's not possible because Huawei doesn't support it. Here you are, the complete 7 layers we are using in data communication or IP data communication, and we are going to have brief introduction and brief discussion about responsibility of each layer. First layer, which is called physical layer. Physical layer, the main responsibility of physical layer, anything physical inside the network, from the dimension of network card, from sending ports, receiving ports, the logic of 1 and 0, and so on. All of those specifications are responsibility of physical layer. Data link layer, the second layer, which is data link layer, the main responsibility of data link layer has mainly 2 responsibilities. First responsibility, which is called physical addressing for the communication between devices. Second point, which is bit error detection. That means if the frame I received has some error, the responsibility of data link layer to discover that frame has some errors, and accordingly it will handle accordingly. Network layer is responsible for logical addressing for the communication between network and each other. Transport layer has mainly 2 benefits. The first benefit is to differentiate between reliable transmission and non-reliable transmission. Reliable means that if the sender sends the transmitter sends the information, it's going to wait for acknowledge. If it's positive, acknowledge, okay. If negative, acknowledge, it will retransmit the data. The second non-reliable transmission, which is called UDP. UDP is non-reliable, means the transmitter sends data. Whatever it's sent or not sent, it will never send back any acknowledge. So, fifth layer, which is called session layer. Sessions simply mean any logical connection open from source to the destination. This is called session. That means its session layer responsibility is to give confirmation that the session start and session end. Layer number 6, which is called presentation layer. Presentation showing the presentation of the file itself or of the packet which is sent. This presentation layer can be in the form of image, can be in the form of sound, can be in the form of video. All of that number of can be compressed, can be encrypted. All of that are examples of the presentation which can be supported by presentation layer. Finally, application layer is going to communicate with our application, and first point of encapsulating data from the application, and after that going to send to the lower layer till it go and send over the physical media. In the diagram shown, we're showing here the relation between transmission node, receiving node, and the 7 layers. As we show here, first, when I'm going to send the data from node B, going to be sent to node A. Very simply, node B, it's going to send that data from its application. First, it's going to be sent to application layer. After that data will be encapsulated layer, either HTTP or FTP or whatever, and it's going to be sent to presentation to showing this data in which format, in music format, in image format, in word format, whatever. Then it's going to send to lower layer till it go to the physical layer, then send to over the physical media. Vice versa, it's going to happen if node A sent to node B, then node B is going to receive that data. Node B is going to receive data from physical, then send to data link, then send to network, and so on till it go to application, and finally application receives this data from node A. In this slide, we would like to summarize 2 concepts according to what we have seen before. 2 concepts called data encapsulation and data de-encapsulation or data stripping. When data like to be sent from application going to physical, it's going to be encapsulated from above layer to the down layer till it go to the physical media. The vice versa is going, when the data received from the source to the destination, it's going to be stripped from layer to the second layer till it go to the application itself. That means simply we can simulate virtually like each layer is communicating with its opposite layer. That means from node A to node B, if we assume that node A is a transmitter, node B is a receiver, application is communicating with application, presentation communicating with presentation, data link communicating with data link, network communicating with network, and so on. Virtually means each layer communicating or understanding the data from its opposite node of the transmitter. This is exactly how data will look like from each layer to the down layer. Means I am going to receive data. For example, if I receive this data from the application layer, it's going to come to the presentation layer. Accordingly, presentation layer is going to add its header to the data received from application layer. When data come from network layer, it will come to the data link layer as data, and data link layer is going to receive header and trailer, and so on till we get the complete frame which sent over the physical media. Finally, in this diagram, the complete conclusion of whatever we have seen from all the previous slides. Accordingly, application is going to receive data from its application. It's going to add its header and send this data to the presentation. Presentation add its part as a header and send to session. Accordingly, session add its part, send transport send to network after adding its part, network adding its header, send to data link. Data link is going to add header and the trailer, header for physical addressing, trailer for bit error rate or CRC to calculate CRC of the whole frame, and finally for bit error rate calculation, and finally send over the physical layer to be sent to the receiver. Thanks very much for joining us in this training, and I hope you enjoy it, and I hope you follow us in all our following training for complete understanding. Thanks very much.